This lesson shows how to determine that a particular graph represents a line in standard form and in slope-intercept form. When working with linear functions, you might use the standard form of a line or the slope-intercept form of a line. In standard form, the equation is written in the form ax plus by equals c. And in slope-intercept form, the equation is written in the form y equals mx plus b. This graph represents y equals x plus 3. This equation is written in slope-intercept form. Here, m is the slope, and it equals 1. It's understood that there's a 1 in front of the x, so we don't write it. You can check that this graph represents this line by picking points from the graph and plugging the values into the equation. Let's take a look at the y-intercept. So here our point is 0, 3. You can check to see if this point is on the line by substituting 0 for x and 3 for y. So we'll write 3 equals 0 plus 3 and check to see if it's true. 0 plus 3 does equal 3, so we can see that this point is on the line. Now you can check a second point. Let's look at the x-intercept. Negative 3, 0. So negative 3, 0 is a point that should be on this line and satisfy this equation. Again, let 0 equal y and plug negative 3 in for your x value. Looking at this equation, the question is, does this work? 0 equals negative 3 plus 3, which is 0, and it does work. So that tells us that these 2 points are on this line, and therefore this is the equation of the line. Now this line, rewritten in standard form, is negative x plus y equals 3. This same graph represents this line as well. Again, we can check this by plugging these values into this equation and seeing if the equation is true. We'll start with our y-intercept again, 0, 3, and we'll check to see if when we substitute 0 for x and 3 for y, is the equation true. So you get negative 0 plus 3, which is 3, and 3 equals 3, so this point is on the line that's represented by this equation. Now let's check one more point. We'll use the x-intercept again. The x-intercept is negative 3, 0. We'll substitute negative 3 in for the x value and 0 for the y value, and we'll check to see if the equation is true. The opposite of negative 3 is positive 3, and 3 plus 0 equals 3. So this point is on the line also. Since both of these points satisfy this equation, we know that this equation is also an equation of this line. Now you know a bit more about linear functions and graphs. See you next time.